So I'm Nicholas Gerasimatos. I work for Red Hat, and this is...
Mandis Mumbach. I am a Partner Solutions Architect with AWS. Well, welcome. Yeah, so today we are going to talk to you guys about digital transformation and why do you want to digitally transform your business, right? So just for kind of an idea for us, for Nick and myself, to see who's in the crowd, who here currently is running some sort of containerized environment or containerized workflow? Right, now, of those who are actually running it on something like Kubernetes or ECS? Okay, who's using something like OpenShift? Okay, fantastic. That gives us a better idea. Can I have the clicker? Thank you very much. So I'm going to bore you guys a little bit with some theory and some ideas, and then Nick's going to do all the fun stuff and talk about the technology while you're really here, right? Because you're not here to listen to me, you're here to listen to Nick.
I don't know, you have the accent, though.
I have the accent that makes me sound right. Yeah, so I'm going to keep with that.
Aluminium.
Aluminium. Okay, guys. Right, so we're going to talk about digital transformation. And digital transformation has become really important to businesses. You cannot, as a business today, whether you are the giant in your industry or if you are the newcomer to the industry, you cannot afford to stay stagnant and not digitally transform your business and take a digital-first approach, right? A company that actually envisions this the best and is the poster child for digital transformation and industry disruption is obviously Airbnb. I mean, Airbnb was able to completely disrupt the industry that they are a part of. They took the hotel industry and flipped it on its head. They were capable of becoming the biggest hotel chain in the world without owning a single piece of property. They are serving millions and millions of reservations per hour, and they are doing that with a team of 5 ops engineers. They are only paying for the resources that they need, so they're not over-provisioning. They're only paying for when they use it and when their customers need it, so they run a very lean ecosystem, and they're able to manage and iterate and deploy their business in a manner that keeps them relevant to their customers. And because they keep themselves relevant to their customers, their competitors are struggling to catch up because they are constantly providing their customers with an experience that they like. And therefore, their customers have no reasons to go to any of the other providers. And this has disrupted the industry to the point that traditional hotel chains are struggling to kind of get to that point and catch up and try and innovate to make themselves more relevant again. And we talk about what these things are that make a company like Airbnb successful. What makes them digital disruptors? And through all of our experience with customers like Netflix and Airbnb and all of the other, what we call cloud-native first-class citizens, we have identified 3 industry shifts and 3 categories that make these customers and these companies capable of disrupting industries. The first is availability. Their ability to always be there when their customers need them. Because if they're not there when the customer opens the website or opens the app, then what's the customer going to do? They're going to move on to the next place, right? Elasticity ties into that as well. In Elasticity, they need to be able to scale out when their customers need them and when it's like, Thanksgiving or Christmas or the vacation season or spring break, obviously they're going to be serving more requests than during the middle of the year. So they need to be able to scale out and not need to keep all of that infrastructure around for the rest of the year and then spend a lot of money paying for that infrastructure. And they need to also be able to adapt quickly if something like that happens. Now, a very, very core part to their success is agility. We are constantly in this industry, in our tech industry, releasing new technologies that make the fantastic and the almost magical possible. At reInvent alone, we launched dozens of services and new features this week. Things ranging from infrastructure right through to the top tier things of machine learning and all those exciting technologies that differentiate that business to a point that serves their customers that it feels like they're holding a piece of magic in their hands. And your ability as a business to adopt that technology as quickly as possible, make that a part of your business, is what we call agility. So being more agile and being able to push out those new technologies, adopt them, make them a part of you, is a very big part of the success of net native or cloud native citizens. So let's talk about availability in AWS. I already gave you a quick definition about it, but the actual theory behind it is that high availability refers to a system or component that is continuously operational. At Amazon Web Services, we constantly talk about the availability of S3. We have a 99.9 to the 11th 9 availability. That means something like 1 in every 200 million, or I don't know, it's a ridiculous number of requests will fail, right? That is what availability is. And the way that we are capable of delivering that availability and how our customers like Netflix and Airbnb is capable of delivering that availability is through our significant range of AWS regions. We have AWS regions that are populated all around the world, which means that you can deploy your applications and your infrastructures in every region that you are serving customers. And you can make sure and you can build for failure to make sure that if there is an impacting event in any of those regions, that you can fail over to a second region. Customers like Netflix have complete failover region schedules and games. They even have open source technologies like Chaos Monkey. That is a testing suite that they can run that literally goes in and randomly destroys infrastructure in their environment to test their failure capability. And they make extensive use of our AWS services to give them that functionality. Now, in the very unlikely event of an AWS region, in one AWS region, you can easily fail over to another one, because we have things like Direct Connect, and we have, this week we have launched inter-region VPC peering, right? But I say the very unlikely event that an AWS region will fail, because the way our AWS regions are constructed is built to be durable and reliable. The first level of durability and reliability is on our availability zones. We have multiple availability zones in each region, which means that you can deploy your applications in 1 or 2 or 3 availability zones. And what is an availability zone? An availability zone is a collection, a number of data centers. Each availability zone has 1 or more DC. And most start around 3 DCs, and we can have up to 6 DCs. And every availability zone data center, or every availability zone, is built in a geographical manner that it is less than a certain amount of milliseconds, like a quarter milliseconds apart in latency from each other, but also geographically far enough, so in the event of something like an earthquake or a tornado, or those type of things happening, that it should not affect another availability zone. Our data centers consist of between 50,000 and 80,000 servers, and all of these data centers are built to be independent of each other. Each of them have their own power supplies, their own connectivity, their own breakout, and their own service teams to make sure that any impact on one DC does not impact the other. We also limit the size of our data centers to 80,000 servers because we don't want larger DCs. A large DC is undesirable because if that fails, the blast radius is bigger. This way, we keep our blast radius smaller. Right. So we have native AWS services that helps you achieve availability in an easy manner. Amazon VPC, which abstracts these ideas of multi-AZs and Amazon VPC through an easy-to-understand interface that you are used to in an on-premise environment or a native networking environment. You specify network ranges and CIDRs, and that translates to availability zones. So your application developers and platform engineers don't need to worry about the complexities of what the AZs do. They just understand the native concept of IPs and CIDRs. We have services like AWS Shield and AWS Web Application Firewall that we front in front of your application as a managed service. That is a transparent service in front of your applications that secure you from things like DDoS attacks, SQL injection attacks, and other things that might impact your performance of your application. And we manage that transparently for you. So any connection that comes to your application gets vetted by a team of security experts that is constantly monitoring the World Wide Web and the transient internet state to make sure that your applications are secure. Services like Elastic Load Balancing and our CloudWatch monitoring, together with our ASGs, allow you to obviously grow your applications and scale out, right? So that's where elasticity comes in. Elasticity is the degree to which a system can adapt to the workload that is required and to provision based on that. So we have native Elastic services as well. I spoke about auto-scaling and our CloudWatch metrics. So you can have an application running in EC2 or ECS or Kubernetes or OpenShift, and you can have custom metrics reporting up to the CloudWatch system or the CloudWatch service. Based on those metrics, you can then define triggers at which point you want to auto-scale your infrastructure. We also make available managed services like SQS and SNS. If you want to build a service that has a queuing, that uses queuing to consume messages, produce messages at scale, SQS is a great service for that. It's a completely abstracted managed service. It scales on its own, it scales independently of your infrastructure, and we will make sure that when you post or consume a message that you will have enough throughput and enough capacity to do that. SNS, if you have an application that is sending push notifications to mobile devices, we can do millions and millions of push notifications with a single API request from your application. Amazon Route 53 allows you to route your application request and your DNS request based on the closest latency for the consumer, and therefore spin up and auto-scale infrastructure in the region that you want, and not over-provision in the wrong region. Agility. I've already made it very clear that I personally believe that agility is the core that makes a company like Airbnb successful. It is the capability to adapt quickly and to smoothly adapt and integrate new technologies with your application that makes you a cloud-native citizen, that makes you an industry disruptor. And that is the key thing that we should all strive to as a part of our digital transformation. Now, all of these things, to be agile is difficult. We understand that there are concepts that we can use, like CI/CD platforms, to give us a little bit of that agility. Being able to push code to a repo and having that propagate through your pipelines and automatically build and deploy is a standard that we have come to know and trust. But it is also something that is difficult to achieve if you don't have the in-house knowledge on how to do that. It is something that is difficult to achieve if you don't have the experience for your engineers and your developers to build that from scratch. So we have worked together with our partners like Red Hat, to abstract that a little bit more for you and to make it easier for you to achieve availability, elasticity, and agility if you don't have the native knowledge and understanding in your business. You all have a product that you are proud of and that you want to focus on. You do not want to focus on the infrastructure and the services around it to make your application work. You want to focus on making a good experience and building a great experience for your customers. So we have application platforms and application platform partners that will allow you to accelerate your development and allow you to easier adopt new technologies and integrate new services. It will provide you with the capability to faster iterate on your applications. Patches, security fixes, ingestion of new technologies. And more importantly, provide a unified experience for your development team, as well as your systems engineers team. Whether the developer is building his application and testing his application on his laptop, or whether he's deploying that application inside of a production environment, the experience is one that is unified. The application deployed on his developer laptop will act and work exactly the same as the application that is deployed into production. And it is as simple as the developer committing his code to a code tree like Git. The industry responded when they understood that cloud-native services and cloud-native customers and businesses need to become idempotent. They need to become transparent and they need to become portable. And how did the industry respond? The industry responded with the containerized standard. So a containerized standard allows for application developers and application engineers and systems engineers to package applications in a way that is easily portable and always idempotent, which means that every time you run the application, the result will be the same as in any environment that it gets deployed in. So an application platform like OpenShift that we will be speaking about today allows you to control that whole environment to make that portability available to you in one easily deployed platform. You start off with something like Atomic Host, which is a small and fast and secure operating system to run your Linux containers in. You can also use a standardized runtime inside of that container to make sure that you have all of the up-to-date security patches and the latest security additions into the trusted runtime of that container. And that is all packaged inside of an open source container framework like Docker. Now, Nick has some insight into what the difference is between a project like Kubernetes and a product like OpenShift Container Platform. So Nick, if I had to understand the difference between why I should look at using Kubernetes or why I should use OpenShift, what are the differentiating things I should keep in mind?
Well, I mean, the main things are Kubernetes is an open source project, right? Google actually helped build Kubernetes. Now there's a gigantic community that's actually helping to further the development of Kubernetes. But Kubernetes is not like a minimum viable product, right? It's not something that is a complete end-to-end solution. It doesn't include the host. It doesn't include a lot of the software-defined networking components and pieces. There's no CI/CD, there's no RBAC or OAuth authentications, things along those lines. Compared to like something, for example, like a product like OpenShift, right? A completely integrated infrastructure that from end to end, from host all the way up to the container runtime, and the containers themselves is actually guaranteed to be forward and backward compatible.
So in Kubernetes, if I use Kubernetes as my application orchestration engine, I still have to do a lot of work. I still need to make sure that my host is secure and up to date with security patches. I need to manage the networking layer, the SDN. I need to make sure that my integrations and my automatic pipelines, I need to build all of that out of the box on my own. But OpenShift kind of just ships all of that for me, and I can trust all of it.
Essentially, yeah. So on the next slide, if we move to it, you could actually see specifically Kubernetes really is just the orchestration piece and actually has some of the storage bits and components in it, right? Whereas with OpenShift, we have everything from the actual host level to the security, the telemetry, so aggregation of logs, metrics, really all the important things that you need. Persistent storage through container native storage, or you could even use third-party storage, right? So you could use block-based storage or elastic file system storage. The container registry, which is obviously incredibly important when you're writing your code and you're deploying your containers, you need to store them somewhere.
Right.
And then obviously the networking and the orchestration piece. So when I'm building something, where is it getting deployed? How is it actually routes being provisioned? How do some of these services or applications know where they're living? And how does the operation team know where they are, right?
Right.
If you don't have anything along those lines and you're just deploying containers out, what happens if you get the same series of containers for an application all on the same host and you lose that host?
Yep, that's true. So OpenShift provides me with the orchestration that I get from Kubernetes, but it also allows me to monitor it better, it gives me the security, and gives me more functionality without me spending time building that myself.
Yeah, absolutely. And I mean, the Kubernetes project itself is amazing, right? I mean, it's open source, it's conceived by Google. Red Hat and Google are currently the top contributors. Amazon is actually starting to contribute quite a bit of code. It's just, if you look at the number of commits and if you look at how it's grown and the new features and how quickly these features are being rolled out, it's really amazing. But at the same time, you're kind of looking at it and you're scared when it comes to a production environment because all these constant iterations and releases, you're never guaranteed that the container runtime and that there's going to be forward and backwards compatibility, right? You don't actually have anything because it is a project, not a product. Then if you take a look at, like, for example, Red Hat Atomic Host is also an open source project that we ended up converting over to a product. It was born from the project Atomic, conceived by Red Hat. And really the idea was to take Red Hat Enterprise Linux and make it as small, fast, and secure as possible with a premise to run it so that you can run your container runtime on it, right? And it was simplified. We used OS tree. You could do configurations through like Cloud Init and things along those lines. But really, it's just one piece of a multi-part puzzle, which is the Red Hat OpenShift project and the solution itself, which is the container platform. So that allows you to actually have pieces like building of automation, CI/CD pipelines, deployment automation, determining where you're actually going to schedule these workloads, setting CPU resources or memory resources and reallocating them when those resources go idle, having the ability to burst when you actually need to. So if you're using something like Amazon and you're running multiple container hosts and you actually need to scale out, you have the ability to do that. And then one of the main things that we're also trying to work on is the ability to not just scale out, but scale back, right?
Right.
So that's the whole thing about ASGs, which makes them absolutely amazing is, hey, I want my hosts to actually be able to scale depending on my workloads, and I don't want to just have to spend money for things to sit idle.
Right. I mean, Kubernetes, the new release of Kubernetes allows for that intelligence to spin up infrastructure as well. And I mean, how easily and how quickly do you integrate upstream changes from Kubernetes into a platform like OpenShift that is orchestrated by Kubernetes?
So, I mean, obviously we want to incorporate any of the new features as quickly as we can, but we also want to make sure that the entire stack end-to-end, from the kernel to the container runtime to the actual containers themselves, are all backwards and forwards compatible, right? So we probably trail a little bit, slower than like if Kubernetes 1.7 and 1.8 come out, right? We're probably a few weeks behind. But we actually do that because we have customers running real production workloads, taking real transactions from real customers.
Yeah.
And the last thing they want in the world is the entire infrastructure to go down and suddenly the shareholders all sell off their stock, right?
Right, but we're talking weeks. We're not talking months or years of delay, right? Like, I mean, we're pretty close to the release cadence.
We're pretty close to
Kubernetes.
lockstep. And OpenShift Origin, which is our upstream open source version, is actually almost in lockstep with the releases themselves.
That's pretty amazing, actually.
Yeah, and I mean, a lot of that comes because of all the contribution that we actually have back to the Kubernetes community. So we actually are helping to drive some of that, technology and where the roadmaps are going. I mean, as we all know, like, containers have been around for years, right? Containers aren't anything new. It's not like, these were just invented. You could look at how C groups, existed, or mainframes,
Yeah. I mean, who out there has played with Linux containers before Docker was around? Name groups and C groups? Yeah, a bunch of us, right? I mean, we know the container ecosystem. So why, if I know the container ecosystem and I know Docker, why should I worry about an orchestration platform or even something like OpenShift?
Well, I mean, okay, so Docker made it really easy to standardize image formats, right? We can all agree on that Docker is the de facto standard for image formats now. Red Hat kind of stepped in and we said, well, you know what? You need a secure and hardened operating system to run that container runtime in those images. And so we kind of stepped forward and started building our ecosystem. And then we realized, though, like, the big thing was, yeah, you could go out and you could take out a bunch of stuff off the shelf. You could go all open source, or you could even buy a bunch of different products and meld them together. But how are you going to guarantee, like, what's inside that container is safe, or it's not going to compromise your infrastructure? Or how will those applications and libraries that they depend on be updated? Or what about my CI/CD pipeline when a new release of Jenkins comes out? How do I know that that's actually going to work with everything? And also, will it work from host to host? Maybe I'm running one version behind in my production environment or in staging or whichever environment, development environment. You want to be able to guarantee consistency, right? You want to have certified container images, certified middleware. You want to have a safe registry, or have multiple different registries that you're pulling from, federated registries in a sense.
I'm a little bit confused, Nick. I mean, the promise that people have made to me about using Docker is that I'll always have consistency, right? I mean, they tell me that I just have to build my applications for containers and I'll have the security consistency that goes with it. You're saying that's not completely true?
Well, you can think of it this way, right? You could go and buy all the parts to build the Tesla, but are you going to build it the same way that Tesla is going to build that car?
Probably not.
Probably not, right? So, are you going to do the regression testing when there's a new software update? Are you going to actually go and determine when parts are actually deemed to be faulty, replacing all those things yourself? Right. So, running containers with Kubernetes, really, Kubernetes is great. It gives you the orchestration piece of it, determines where your workloads are being placed, it determines auto-scaling and a few other things. Then you need, obviously, some way to actually store your container images, right? So then we started adding things like the Docker registry. Then you need networking. You have to actually know what's talking to what should be exposed to what, how these things should be talking to each other, not just on the same hosts, but what about on multiple different hosts, or what about multiple different environments? What if some of this stuff is actually talking back to Dynamo in a sense, right?
Yeah.
So how am I going to start, making sure that all of these things are going to be compatible with those ports? And
so if I really want my application to be scalable across multiple nodes, then I have to put another layer of networking inside of it.
Typically, yes. Yeah.
Okay. And Kubernetes doesn't do that for me.
No.
Right.
And then, the other aspect of it is like persistent storage, right? So, in the early iterations of containers, they were great for stateless applications. And then a lot of people started saying, well, I have a lot of these legacy applications. Maybe they're older mainframe applications that they wanted to migrate over. And they needed to be highly available, and they needed to have things like shared storage and persistent storage, because if a container failed, it needed to be able to start up on another host. And those those artifacts, whatever they were, needed to be preserved, right? So that's another thing that you had to take into consideration. So things like container native storage that we help build, which is essentially Gluster and a combination of Fuse that actually builds a pod that ties directly to the container. If the container moves, then that storage can actually move along with it.
Okay.
And then obviously, other things that you need, telemetry, right? Logging, data acquisition. Financial services companies need to be able to actually understand when transactions are being done. We have to go through auditing and things along those lines, right?
Yeah, so we're not just talking about basic monitoring here. We're talking about in-depth, like understanding what's happening in the application and application level metrics that we can expose.
Absolutely, yeah. It's not just the metrics, it's the logging. It's, what happens if my container doesn't start? Being able to debug it and have an easy readable code. Or the ability to actually get into the shell and not have to SSH directly into the container host itself and then actually plug into the Docker runtime, right?
Yeah, getting into a host in something like a Kubernetes cluster can be a pain, man.
Yeah. Well, and then you have to determine where is that pod running to begin with too, right?
Yeah.
And then obviously you need security, you need RBAC, you need OAuth, you need built-in security plugins, whatever. One of the big things that we really were looking at when we were building some of the OpenShift stuff is Kubernetes is great for one project, but one company is not just using one project. There's many different products. There's many different groups that are working on a lot of these things together. And you don't want to have one group have access to someone else's stuff, right? Whether it's the registry, or maybe it's the actual container images or the infrastructure, or maybe it's resource quota management, things along those lines. And then also tying into like OAuth, right? And then SE Linux to guarantee that the kernel and that the actual runtime is hardened.
So if I'm running Kubernetes as my company's deployment process and I've got my applications running in there, but I don't want my different teams to be exposed to each other's code or each other's data, do I need to do a significant amount of work to make that happen?
Out of the box, there's not really anything that's, directly integrated into that project, right? It's the main difference between project and product.
Okay.
And then if you want to talk about defining as code.
Yeah, I mean, that's something that I'm really passionate about. As a developer, I am a developer, right? That's where I come from. So for me to have that unified experience and to be able to push through everything to the end and make sure that when I deliver my application to the team that's going to deploy it, it needs to work the same way that I did. I hated those discussions when I was put my life and soul into an application and I was developing and I was taking hours of my life out of that and it runs perfectly in my dev environment. And then I give it to our deployment team and they come back to me and say the application doesn't work. Right?
Yeah.
I mean, it's soul crushing for me as a developer, right? And it's not their fault. It's because I built it in something completely different that they did.
Or different runtime version, different version of Java, whatever.
Exactly, right? Yeah. There were so many different things that go wrong. Or where they come back and they go like, well, you're using this library that our NetSec team hasn't secured, right? That we haven't whitelisted yet. So I need to then completely refactor my code to make use of another library, right? And that could have been stopped if I had that unified environment that I was running in. So the definition of code is really important for me. The ability to build my application inside of my own environment on my developer laptop, define the code as an idempotent spec, a YAML specification, and then posting that application definition into any environment, whether that is my on-premise environment, my dev environment, my cloud environment, and being confident that that actual deployment will be transient. It will be the same thing every time. I can have confidence that it'll run the same way that it was meant to run while I was developing it. So that's really important for me. And then I started, another thing that was really great about this is that not only do you define your application code, but also the requirements and dependencies around that code, right? So if I'm a developer that needs a database, then I need to define that inside of my spec as well. Right. And traditionally, I used to wait weeks and months for my engineering team, my sys engineering team, to actually provision a database if I need a database.
I remember those days, yeah.
Yeah, man, it was frustrating. I mean, I would work really hard, and my manager would be on my back, and he'd be like, I need that code tomorrow, and the code would be done, but the database wouldn't be there.
Or the storage isn't provisioned yet on top of it.
Or the storage hasn't provisioned yet, or anything like that. And I would just basically be sitting there waiting for them to do that for me. So all of that, being able to define that in my spec and self-provision the dependencies that my application need is really, really important for me.
Yeah, self-service is the holy grail.
Exactly, right? The self-service thing makes my life so much easier. And the nice thing is, all of these dependencies get managed by OpenShift and made sure that it is exposed in exactly the same way in any environment. So whether I do it in my hybrid environment or in the cloud, it's exactly the same. So we at AWS Services decided that we needed to expose some of our managed services, right? Because you guys know that we have services like RDS, which is a managed database service, and we have services like EMR, which is our Elastic MapReduce service. That is a completely managed service that customers don't need to worry about. They just provision it and make it available. But traditionally, how it works today, if your developers want that, you probably have an ops team that goes in and provisions it, sets up the IAM permissions, and does all of that hard work for you, and then finally it gives the connection string and URL to the developer to integrate into his application. That's still not a self-provisioning kind of experience. And the developer needs to understand how AWS works, they need to understand IAM credentials and all of those type of things, and that's not a great experience for the developer.
So how does that tie into like high availability then, when you're looking at like containers and then tying into some of the cloud native services of AWS?
Well, that's a good question, because if I'm running a high availability cluster that's spaced across availability zones of multiple regions or environments, if my application needs to die, or the container dies on one host and moves to another host, they need to be able to connect to the services that were provisioned, or the new service needs to be brought up and restored to the state that it was previously. Okay. And it needs to be done automatically. So the AWS Service Broker is something that we are working with Red Hat. And we are very, very excited that we launched it this week. We actually open sourced the code yesterday. It's available on GitHub, and everybody can go to our AWS Labs repository and check out the code and look at our documentation to see how you can use it. But let me tell you what the Service Broker does. The Service Broker is built around the Open Service Broker API, which is an industry standard API that has been adopted by platforms like Kubernetes, OpenShift, and Cloud Foundry right now, and other platforms will be adopting it soon. So it's an industry standard that allows you to provision third-party services in these application platforms. So basically what the Service Broker does is it kind of acts like a little bit of an artificial Alexa, right, inside of the OpenShift platform, or inside the platform, where the application developer in that YAML definition that we just spoke about can do something like, Service Broker, give me an S3 bucket, right? The developer doesn't need to know how to set up an S3 bucket. The Service Broker will do it for him.
Yeah, I'm waiting for you to program that so that I can actually, start provisioning different things through Alexa.
Well, maybe we could. We can do that with OpenShift, right? We can build an OpenShift trigger and an Alexa skill easily to deploy my application. I think we should do that as a chalk talk next year. That's something that we could do to do fun. So yeah, so with this Service Broker, the application developer will be presented with something like this, right? This is a snapshot of what the console looks like when you go into the OpenShift platform. And you'll see that there's a list of AWS services that the developer can then choose from. So if the developer wants to provision a Redshift cluster, they just click on the Redshift cluster, it brings up a little pop-up, and that would ask them for things like a Redshift cluster name, for example, right? And what size they want the cluster to be. And the platform itself, without the need for the developer to go into the AWS console or use the AWS CLI or any of the native APIs, the platform itself then goes and provisions that resources for the developer.
So I, as a developer, never have to go into the console?
You, as the developer, never ever need to touch the AWS API. You don't even need to be aware of the AWS API. The service does it all for you. You just work against the OpenShift platform. Wow. And you can either do it in the console by clicking and using your mouse, or you can use the OpenShift CLI, or you can use the YAML spec definition and provision it as a service, just like any other service that you provision in OpenShift.
Has anybody here had a chance to look at any of the Open Service Brokers?
Right, we have a couple, well, one or two, which is great, actually. Okay. Considering we only launched it like yesterday, right?
Yeah.
So that's fantastic, and it really accelerates that development, because now as a developer, I can provision that inside of my application, and it's a self-provisioning process. So when my manager expects my code to be delivered, the infrastructure that my code depends on will also be ready.
Yeah, right? and for me, like when I develop, I don't want to wait and or more importantly, I don't care where it gets deployed or how it gets consumed, right?
Exactly.
I want the operations team to kind of set those policies, and I just want to go and click the things I need and go build it out.
Right. So I don't want to worry about the networking layer and the communication layer between the application and the database and all those type of things. My platform needs to do that for me. So my business manager can just ask me to change something, or they do these they do these touch things where they ask the customers for feedback, and the customers give feedback. We make changes. We might need to change the backend database or something like that, and that's all self-provisioned, right? Wow. So that gives us that agility that makes a company like Airbnb really successful.
Yeah.
So The launch catalog that we built into the AWS Service Broker has started with 10 services. So we open sourced 10 native AWS services and exposed 10 native AWS services through the launch catalog. And those are the 10 services that you can see on there. The ones that I'm really excited about are fully managed services, the ones like Amazon Athena, that allows you to directly query data in S3 through a JDBC connection. So
Wow.
if you have tons of terabytes of data or gigabytes of data or petabytes of data in S3, you don't need to wait for the provisioning time of an EMR cluster or a database or something like that. You just connect to the Athena JDBC driver, run your query, and get the results.
And I'm assuming that's scalable too.
And that's totally scalable. I mean, it's infinitely scalable. And it's automatically provisioned for you. So the platform goes, it sets up your schema definition and everything for you, and then it returns the connection string as well as the JDBC driver that you need to actually query the application. Another fantastic thing about the application service broker, or the AWS Service Broker, is that you don't need to run your OpenShift platform or your OpenShift deployment in AWS to use the AWS Service Broker.
I don't understand.
You can deploy the AWS Service Broker in your on-premise environment as well.
Wow. Okay, so I'm running OpenShift in my own data center. Maybe I'm running OpenShift in AWS, and I'm using S3 for my storage.
Yeah.
I can provision S3 from either of those locations.
You can provision S3 from either of those locations using the AWS Service Broker. The service that you provision will not be provisioned inside of your data center,
Right.
but they will be accessible by your data center.
Wow.
Right? So that unified experience that we were talking about, that still exists. You don't have to change the way that your applications work between your on-premises environment and the cloud, because it's a unified experience. You can deploy the service broker in both locations, or even one location and have both locations work off the same.
Or multiple regions or whatever.
Or multiple regions or whatever environment you want to do. So, as a customer of AWS and a user of OpenShift, what this really means to me is that it gives you this really tight integration to AWS native services, which makes you capable of adopting more native application development cycles for your business, right? And that makes you more cloud native. And ultimately, it digitally transforms your business to a point where you can be as agile and elastic and as available as a company like Airbnb. And then with the usage of our regions, you get this global footprint, so you never need to worry about going offline if you build for failure. You get that additional security layer that we've come to know and trust with something like the Project Atomic and Red Hat Linux. And something that we really want to emphasize in our in the Red Hat environment and the container environment is this really extensive partner ecosystem that we have. The partnerships that AWS and Red Hat are building together with the greater ecosystem and what we're constantly iterating on and adding new features. And this is leading to the service broker only has 10 services today, but we aim to have almost all of our services available in the service broker by Q2 next year. So services like recognition, right?
We have a lot of work to do.
We got a lot of work to do, but we're hard at work, and we're working very hard with the Red Hat team to make that a possibility. So, I mean, the recognition is going to go in, Poly is going to go in. All of these services that we launched this week that everybody's so excited about, the ML services that we launched, all of those services will be available in the service broker very soon next year.
Very cool. So really, I mean, to kind of summarize, right, OpenShift, the general design of it is to build, deploy, run, orchestrate, and manage container-based applications. And the key word is really at scale, right? We wanted to be able to make it easy to manage production-based environments or development-based environments at scale. And what it consists of, if we move to the next slide, it's not really just about running containers, right? We all know we can run containers on our laptop, we can run containers on an individual host, it doesn't really matter. That's not really interesting. Where it gets interesting is when you start looking at like Docker build and Docker compose or doing source image where you're actually taking code that you're checking into like your GitHub or your Jenkins and doing some type of artifact repository and pulling that information out and actually building code on the fly. So whenever someone makes a commit, it actually triggers a new build. That's where it becomes interesting, right? Then you need deployment of those images. Where are they going to go? Where are they going to land? How do I guarantee high availability of where these applications, these containers, these projects are actually being distributed? And then on top of it, from an operations perspective, how do I know if there is a problem, what host it's running on? How do I actually, reverse engineer and start understanding? How do I get those logs? How do I see those metrics and utilization? And then obviously having the ability, to do like rolling A/B, blue-green deployments, right? multi-tier storage, so gold, silver, bronze classifying of storage, multi-container applications that spawn multiple pods. That's where things start to get really, really, really complicated, right? Then you look at reusable components. What about internal and external service discovery? So I'm provisioning all these different services. Wouldn't it be great if they actually could just figure out, without me having to tell them, what ports are open and how they should be communicating and actually routing traffic?
Yeah, and I mean, that's great. What if my business unit inside of my company builds a great utility for authentication, like a transparent proxy application, right, that just completely authenticates the users that are using my application. Now, other parts of the business that might need that same functionality can just reuse what I've already built. They don't need to go and re-engineer the wheel, I guess?
No, you don't have to go throw it all out and just start, use what you built.
Right, so again, that faster iteration thing now starts taking a little bit more toll. Great.
Yeah, so really, then you look at the fact that there's, self-service user experiences so that they can actually go in. You leverage things like the open service broker, right? They can actually, deploy applications from their Git repository. They can actually share this information. They can share the registries between one another. Really, at the end of the day, if you move to the next slide, it's a full platform, right? You're talking about the operating system running on top of AWS. You have your packaging format, your security, your telemetry, your logging, your resource allocation, metrics, the ability to actually set hard limits on those and soft limits. Setting them to auto scale, which I think is always really cool because you just open up the UI and you just say, hey, give me 3 of those, and it just does it, right? How awesome is that?
That's great. Yes, okay, so just to kind of recap for my own mind here, we spoke about a bunch of things right now, and I got lost around the middle when we were talking about Kubernetes, and when are we talking about Kubernetes and OpenShift, right? So let's review this quickly. In Kubernetes, I get the orchestration. I can basically deploy my containers, my already built containers that, that's there, and orchestrate that, which means that it'll basically deploy them onto different hosts based on the amount of CPU power and memory power they have, right? But if I really truly want some form of automation that does
granular,
granular automation and things like security checking and making sure that my platform deploys in a unified manner, the attachment and detachment of storage and transferring that storage as the container moves around and all of those type of things, then I either need to go out and build it myself on top of Kubernetes, or I use something like OpenShift that already has that natively in it, right? Is that a fair summary?
That's a fair assumption, yes.
Great. Okay, cool.
So, just to recap, the OpenShift Container Platform is basically a runtime packaging format, orchestration, cluster services, the registry itself, the telemetry for logging, for data allocation, the ability to actually look at the container runtimes, the automation, all of these different things on here, right? And go ahead.
Oh, yeah. So, okay, this is great and already sounds good, but I'm thinking as a developer again, right? As a developer, that kind of probably imposes some things on me. Like I said earlier about the fact that I want to use certain libraries and I need to make sure where those libraries are secure stuff. That's still a lot of work for me as a developer. Is there anything that I can use that'll make my development of an application for this platform a little bit easier?
Yeah, so we actually developed the container runtime kit, or the CDK. You can run it on any operating system for the most part. You could run it on any hypervisor. You select your target host. So you can actually build out your development and stuff on your own laptop or on specific hypervisors if you want, and then actually take those contents and then deploy them. The CDK is actually free. We give it away entirely, and you can actually run OpenShift locally on your laptop as part of the CDK. So instead of having to run Minishift or OC Cluster Up, for those that are familiar with it, you could actually run everything through the CDK and actually use this like Eclipse and a bunch of other stuff. You could bring libraries into it. It's really, really, really powerful.
So my security team, for example, can take the CDK, the open source project, kind of build their version of the CDK for each of our developers to use, and then if I just stick to what's in there, I know that my application will be green light basically from start to finish. So again, it's just really easy for me to develop, deploy, and make sure that everybody's happy and my manager's off my back.
Yep. Absolutely.
I'm sold on that idea.
And then we have other things that we tie into. So it's not just the container platform for high availability and monitoring and understanding metrics and workloads and where things are actually allocated. We started tying into things like CloudForms, right? So that you actually have the ability to say, this pod runs on this host, which is consuming these resources in AWS, which therefore is generating this much money. Like having that ability to have that much granularity and understanding what a pod is doing and what it's consuming and what it's costing me, or maybe when I need to actually start setting some triggers to actually, scale. Really, it's like a single pane of glass management, right?
Yeah.
And the ability to also tie that directly into your AWS infrastructure and pull information from your AWS infrastructure. It's kind of like you're getting the best of all worlds in a sense.
Right.
And by the way, that's free with OpenShift. We actually don't charge for CloudForms. It's directly integrated into it.
Hey, Nick, what's CloudForms?
So CloudForms is our cloud management platform.
Right. So does that mean just manage your cloud, or does it manage other things as well?
It manages, well, it could do a lot of different things. You could use it for self-service portals. You could use it to actually manage OpenShift clusters. You could use it to provision services and workloads on AWS. You could use it in your current environment. If you're running VMware stuff, you could tie it into that as well.
So I can transparently manage both my on-premises environment and my cloud environment through one portal.
And your containers and your pods and
And
your
my
hosts.
containers and my pods and everything in one place.
Yeah, and you could plug it into things like Satellite and Insights and Ansible Tower to do all of your deployment. So really, it's kind of like the glue that sticks a lot of stuff together.
That's pretty cool. And these will monitor and notify me if anything on my infrastructure layers are not acting the way I expect them to?
Absolutely. Yeah, we have a lot of people that use it. They tie it into like self-service catalogs in a sense, right? They provide a skin around it. And then when someone says, hey, I need this size of a container or a VM and this geolocation that meets this criteria, and it sends it off and gets the approval, and it actually builds it and deploys it.
Right. So the developer can say what he needs, he deploys his YAML, and
yeah, because going back to the same thing, like I'm a developer, I have a timeline, I need to get things out the door as quickly as I can, right? We live in the world of perpetual beta right now.
Yeah.
So, every morning I wake up and my phone tells me I have 53 apps that I need to update. It feels like I'm never up to date when it comes to anything.
Yeah, it's because we have so many new technologies coming out the whole time, right? People are really racing to keep up to date. And I mean, the apps that I'm using are the ones that have the latest technology, right? If they can do OCR scanning on my receipts, I'm going to use it.
Yeah, and then the Red Hat Cloud Suite really kind of ties all of that stuff together in a sense. So infrastructure as a service, platform as a service, unified management framework and orchestration for hybrid models, the ability to seamlessly manage infrastructure to applications, your middleware, whatever. So that really kind of like ties the entire suite together if you're looking at CloudForms and OpenShift and running it on AWS in a sense.
Yeah, that's great. So I know that OpenShift can sometimes be a daunting thing to deploy. I know that you guys did some really...
All container platforms are.
I know, right? I mean, it's a pretty difficult thing to do. And I know that Red Hat did some fantastic work on the OpenShift Ansible playbooks, right? And guess what? We at Amazon kind of noticed that, and we decided we want to take that a little bit further, right? So we built what we call the Red Hat OpenShift QuickStart, right? Which is a reference architecture that leverages that technology that you built into the OpenShift Ansible spec, as well as our native Lambda features, right? Which is our serverless application service, compute service, to build a QuickStart that automatically deploys a completely reference architecture observant deployment of OpenShift.
So how complicated is it to deploy this?
Absolutely not complicated at all. You go to that link or that URL that's down there for the OpenShift QuickStart, you click on it, you type in the name of the cluster you want, and you click launch. That's basically it.
That's it.
That's it.
It builds all this.
It builds all of that. It gives you 3 master nodes and 3 availability zones, right? So that high availability thing we spoke about, you get that immediately. It deploys 3 infrastructure nodes in 3 availability zones.
What about load balancing?
It puts load balancers and everything in front of your application so that it automatically load balances your application requests coming in, and it uses the AWS ELB service, which is a known and very trusted service, and which our customers are in love with. And we also put all of our infrastructure nodes and our application nodes, and even our master nodes in auto-scaling, auto-healing, auto-scaling groups, right?
So is this based on like the reference architecture deployment stuff?
It is, indeed. It is completely based on the reference architecture that you guys wrote up.
Wow.
So it is exactly that. It's a reference architecture deployment of OpenShift, and it's a one-click deployment. You don't have to have extensive knowledge of how to use Ansible or OpenShift playbooks or anything like that. You just go to the website. It's a CloudFormation template. You ingest it into AWS, and AWS will launch all of the infrastructure that you need.
So what if I'm interested in like exploring, OpenShift? I'm already running a container platform. I want to know a little bit more. Like, what are the next steps with that?
Well, the next steps for you is to basically contact any of us. There's an alias that we have that you guys have set up, and we're all monitoring it. And you can reach out to us, and we'll work with you. And if you have a customer that wants to try it out and play with it, or if you are a partner that wants to get more education on it, we can do a POC with you. So we have a POC program that is currently going, and where we will actually give credits towards your AWS bill, and you guys will be giving credits towards the OpenShift licensing.
Oh, wow. Okay, very cool.
Yeah, so anybody can play with it, and we are super excited about doing this with our customers. Oh, there we go. That's the POC program. If you want to get involved, you just reach out to Muncie. You got the email address there, or you can send it to the AWS NA Red Hat alias as well.
What if I'm like a solutions provider, solutions integrator, and I want to get experience with that? Can you do that as well?
You can use the exact same email address and just send us, and please let us know what you want to do.
Okay.
We are looking for SIs, and we're looking for partners that will work with our customers and do all of that. So I think that's everything I've got to say. Do you have anything more to say?
No. I mean, that's a lot to cover, so.
Yeah, so I think everybody's tired of listening to us, but I think there might be a couple of questions in the audience. Is there any questions that you might have?
For a company that's already purely AWS cloud, how does this compare to like ECS or EKS?
Great question. So the question is, for a customer or a company that's already running in AWS, how does this compare to our services like EKS and ECS? EKS that was just launched recently. Like we said earlier, there's a difference between Kubernetes and OpenShift, right? Now, Kubernetes is more akin to EKS and ECS than OpenShift is. It's again, you can use EKS and ECS manages some of the cluster management and autoscaling for you, but getting that automation, that security, that agility, the pipelining, the trusted infrastructure and the trusted runtimes, all of those things aren't available in that. If you want to use those services, you need to go and build those parts out and manage and own those parts again on your own as well. And for some customers, that's a way to go. And if they're available and they're capable of doing that themselves, then they should totally do that. OpenShift provides them with that all-in-one solution, a single pane of glass that helps them focus on their application rather than building ancillary projects and applications around the basic container orchestration.
And the great thing is also single throat to choke too, right?
Yeah.
So if something goes wrong, you don't have to contact 19 different vendors to actually figure out where the problem is specifically lying. I don't know if you've been there, but I've been there before. In a previous role, I was actually a director of cloud services, and we got stuck in the blame game where every company was passing it off for 24 hours while our infrastructure was down.
That's actually a very good point. We didn't even really mention that, but with OpenShift comes that support relationship that you get with Red Hat, right? So you can literally phone them up and say, hey, this isn't working, tell me why. And that's not something you get with open source projects. And with a managed service like EKS, you get a certain amount of that, but it breaks down when you start thinking about if you're introducing something like Concourse for your pipelining, right? Who do you phone if that breaks down, and so forth. Do we have any other questions? That must be a good sign. I guess we either put them all to sleep or, oh, wait. Yeah. Oh, we've got one here in there, so let's take this one quickly.
I have a question about the self-service part. So for example, I have a YAML deployment for service, and also I have things like give me S3 bucket and provision RDS. So I have two questions with that. So for example, can I restrict developer so he will not create a database bigger than X?
Yeah.
For example, and when the developer decides to delete all of it, so the S3 bucket and the RDS will be deleted also.
Yes. Okay, so the question is, in the self-service model and using the AWS Service Broker, first question, can I restrict the resource sizes that they are going to provision and how much each, and what services a developer can provision? And secondly, if they deprovision those resources, does it get cleaned up inside of your AWS account as well? So those are the two questions. The first question is, yes, you can have complete control over the services that get exposed to each project and to each platform, and what type of services they are allowed to provision, and what sizes, for example, in RDS. And the second one is the underlying technology that we leverage from an AWS perspective to make the service broker work in a compliant manner is our CloudFormation technology. So when the deprovisioning process gets kicked off, CloudFormation goes out and rolls everything back. So yes, it cleans up completely after it gets deleted as well.
And of course, you have the security to make sure that they cannot delete that unless they're allowed to.
Yeah, and because the service broker fits in with the complete role-based access control features that OpenShift have. Right. Any other questions? There we go.
Absolutely.
Okay, so the question is, will OpenShift have Windows container functionality and support in the future?
Yeah, so we're working very closely with Microsoft on building native Windows technology for management of containers. So I could give you a little bit more information on that off stage. We could just talk about it.
Yeah, and when OpenShift supports it, it'll be supported natively in AWS as well on day 0.
Yep.
Yeah. Any other questions? Yep.
Yeah, QuickStart be deployed. Can you deploy Origin as well as?
You can.
Yeah. So the question is, in the QuickStart that we have, can you deploy OpenShift Origin, which is the upstream version of OCP? Yes, you can. In the QuickStart, you'll have a choice between OCP and Origin, so you can deploy either two.
Yeah, the main difference is between the two. If you choose OCP instead of like the Origin versus the actual container platform or enterprise-based product, is you have to use your RHN account to log in to actually pull the subscriptions. If you use Origin, you don't have to worry about doing that.
Yeah.
Can I use an external Jenkins master to orchestrate the CI/CD pipeline?
So the question is, can I use an external existing Jenkins deployment to automate my pipelining? Yes, you
Absolutely.
can. Absolutely.
Absolutely. We bundle Jenkins directly with it, but you could use as many different build tools that you want. So if you have multiple different Jenkins deployments, maybe you're separating or segmenting your staging from your production from whatever, you can directly tie that into it. And then you can actually set the authentication so that only users can actually pull code and run code directly from certain Jenkins servers.
I saw a hand there. I don't know if you just woke up and stretched or if there wasn't actually a question. Okay, you just woke up and stretched out. Cool. Any other questions? Right.
Yeah, you mentioned support for the newer version of Kubernetes. It seems like Rancher and Mesos and all are also saying, oh, first quarter we'll have this thing ready, but they don't really have like a useful beta or alpha or not. How far along are you guys, and do you realistically think we'll have something like first quarter?
So the question is, how realistically do we think the latest version of Kubernetes will be available in OpenShift? Nick?
So in OpenShift Origin, it's pretty much almost lockstep. From the time that it goes GA, we're already starting to roll it into Origin because Origin is our upstream. We then, therefore, work out all of the bugs and issues and really kind of focus on the big things that are being introduced in the iteration of Kubernetes. Like, a lot of people are really interested in federated masters, in a sense, right? So those are big things that we want to incorporate in the next version and iteration. So usually, we're usually a few weeks behind for the most part, but it's not quarters or half a year or anything along those lines. It's moving too quickly at this point. If we were to wait that long, we'd be going from 1.7 to 2.0,
I think one of the things that need to be kind of made clear is that the OpenShift platform doesn't actually alter the Kubernetes deployment.
Correct.
It uses the basics upstream deployment. It just the OpenShift platform interfaces with the native Kubernetes APIs. It augments it. So they don't need to go and change anything or backport any code changes or anything like that. They literally can just consume it as is, and the OpenShift platform will work. Why there's a delay in the OCP deployment is that they need to make sure that it's hardened, because with OCP, which is the container platform, the licensed one, they put a stamp of approval saying that we will support this. So they need to make sure that whatever was changed in the upstream is actually not affected or broken. Or
that ties to like our legal compliance and all the other things that Red Hat brings to the table when it comes to RHEL and.
But Origin is basically just available.
Yep. Any other questions?
Cool. I think that's it. Thank you very much, everybody. We really appreciate it. And enjoy the rest of your reInvent. And don't forget about tonight's replay party. It's going to be a pretty big one.
I heard it's going to be insane. You guys built a bridge for it.
We did. We built a bridge over the road, so that's fantastic.